Hi everybody, welcome to another Chats with Chaudhry. I hope you're all safe and well. Today I'm joined by Gaby Kaiser, who is Business Field Manager for Pharma, Cosmetics and Food at Netzsch. Hi Gaby, how are you?
Fine, thank you. It's nice to meet you.
It's lovely to see you. I'm glad you've got the orange background. That's my corporate colours as well, so that's all good. So today we're going to be talking about small molecules, the impact of micronization on the properties of a drug, and how it can be optimized by analytical means. But before we start doing that, perhaps you could tell the viewers a little bit about Netzsch and your background.
Netzsch is a family-run company with its headquarters in Celp, Germany. Celp is a small town in northern Bavaria. The Netzsch Group consists of 3 business units: pumps and systems, grinding and dispersing, and analyzing and testing. I am working at the business unit analyzing and testing. It is one of the leading manufacturers of thermal analysis instruments with an experience of more than 50 years. At the beginning of this calendar year, Netzsch Analyzing and Testing expanded its portfolio by taking over Kinexus and Rose and rheometers from Malvern Analytical, because rheology is an ideal completion to thermal analysis. I am a chemist from education, and I'm with the Netzsch company for about 28 years, working with thermal analysis instruments and on thermal analysis applications. The position of a business field manager for pharma, cosmetics, and food, I am holding now for approximately 2 years.
Right, okay. Now, obviously, since February, most companies, or if not everybody, has been affected by COVID-19. How has Netzsch managed the situation, both from an employee internal perspective, but also in terms of how you've been dealing with your customers?
In Germany, the COVID-19 lockdown was not that strict, although there were limitations. People were allowed to go out. For example, employees in industry could go to work, but nevertheless, many people stayed at home and made home office. At Netzsch, where it was possible, many colleagues were working from home too. But what we introduced during that period was a virtual lab visit. So this means that people who are interested in instruments, evaluations, measurements, etc., were able to do that online, and this is still possible.
Right, and how does someone then book a virtual lab visit with you?
The best way is to get in contact with a local Netzsch representative, and then he or she will arrange for such a virtual lab visit.
Brilliant, okay. So, what is micronization and what does it mean in terms of the applicability of a drug substance?
Nowadays, many chemical entities are belonging to the BCS classes 2 and 4, which means they are poorly soluble in an aqueous environment. Class 2 means low solubility and high permeability, and class 4 means low solubility and also low permeability. People try to improve the solubility of such substances and also their bioavailability by various measures. One of these measures is to reduce the particle size. Of course, small particles can be synthesized, but very often they are produced by micronization. And a still commonly used technique to reduce the particle size is milling or grinding.
Right, but if you use mechanical treatment of substances, don't they influence the physical chemical properties of those substances?
Yes, it's possible. It's possible for APIs, which means active pharmaceutical ingredients, and also for excipients. Caused by a mechanical treatment may be a phase transformation. This means from one modification to another one will be induced, or a crystalline substance may be transformed into its amorphous state, which may be or which may dissolve faster, but is often just metastable. amorphous means lacking a three-dimensional long-range order of molecular packing.
Right, okay. So how can thermal analysis be of help in this case?
Differential scanning calorimetry, DSC for short, can be primarily mentioned here. It is the most widely used thermoanalytical technique for characterizing pharmaceuticals. With DSC, it's possible to investigate melting effects, crystallization effects, glass transition effects, for example. Glass transition is a characteristic for amorphous or partially amorphous materials, and to study melting behavior. The melting behavior is important, for example, for regarding the crystallization of materials or the polymorphism of materials.
Right, okay.
Many polymorphic forms can clearly be differentiated by their melting temperature.
So what is important for the application of a micronized drug? Should it be administered in parenteral dosage form?
If a micronized drug shall be administered intramuscular or subcutaneous in the form of a suspension, it should be possible to draw up the suspension in a syringe easily and afterwards to reject it from the syringe readily. Both syringeability and injectability are, amongst others, related to the viscosity of the suspension. So this means viscosity is an important point. In addition, there should be no permanent segregation and sedimentation of solids during the storage of a suspension.
Right, and how do you measure the viscosity?
Viscosity is the resistance to flow, but this is not only a number, it's a function of temperature and also of shear rate. The shear rate can be described as a flow velocity in relation to the geometry in which the sample flows. The dynamic viscosity can be determined by means of rheometers. Rotational rheometers are dedicated to the low and mid shear rate ranges, capillary rheometers to high shear rates. A viscometer, on the other side, is covers only a limited shear rate range and usually does not offer the possibility to get information about the shelf life of materials.
Right, okay. Well, that leads quite nicely on, as I understand Netzsch have a special promotion running at the moment where you can actually get a special discount off a BSC instrument and a Connexus rheometer. First, why is it, how are you having the two together anyway in terms of workflow?
With a differential scanning calorimeter, which means DSC, in combination with a rheometer, it's possible to cover a broad range from the investigation of fundamental material characteristics, for example, for an active pharmaceutical ingredient, to formulations and to practical directly application related questions of dosage forms. This is also reflected by the title of the promotion, which is the perfect duo for advanced research and quality control. The offer is limited to Europe. This means to the European Union, to the UK and to the EFTA states, as well as to the US and Canada. And it's valid by the end of this calendar year, which means until December 31st, 2020. For more information about application, but also about this offer, please check our website, www.netsch-thermal-analysis.com. And please remember that Netsch is spelled N-E-T-Z-S-C-H.
And viewers, just to let you know, Gabby was not reading that. That was all in her head. She memorized that. But if you couldn't memorize that as well as Gabby, just click on the link above the video and you'll be able to see the correct spelling, and it will take you straight through to not just the promotion, but also to find out more about different solutions that Netzsch offer, the different workflows they help, and also with lots of additional resources to help you in terms of your applications. So all that's left for me now is say, Gabby, thank you very much for taking the time out to talk to me today.
Thank you very much.
And to everyone else, it was. I hope you found that useful and interesting. If you'd like to know more about micronization and about Netzsch, click on the link or leave Gabby a message in the comments section below. I'm sure she'll be happy to answer any questions you have. And until next time, as always, stay well and stay safe. Bye-bye.
Have a nice day. Bye.